All right. Welcome everyone. In this webinar, we'll be covering Spark and Cassandra, and we're going to have a little demo showing how you can do SQL and joins on Cassandra tables. Just a friendly reminder, if you have any questions, please direct them in the chat, and we'll get to them when we get to a good stopping point or at the end of the demo. So a little about me. I'm an apprentice here at Anant, joined in December 2019. And this webinar, SQL or Spark and Cassandra, is part 2 of our series on doing SQL and reporting on Apache Cassandra with open source tools. Part 1 was with Presto and Cassandra, and there's a video on our YouTube channel, youtube.com/AnantCorp. And then there's also a blog here. When the slide deck is up and the YouTube is up, everything will be linked, and you can click on this, and the blog post has an introduction to Presto, the demo in a written format, and then also the link to the video if you want to watch it there. All right, a little introduction about Spark. Spark is a unified analytics engine for large-scale data processing, and achieves high performance for both batch and streaming data using state-of-the-art DAG scheduler, query optimizer, and a physical execution engine. It offers over 80 high-level operators that make it easy to build parallel apps, and you can use it interactively with the shells that we'll discuss in a little bit. So there's the main one, Scala, there's Python, so PySpark, R, and then the SQL shell itself. It powers a stack of libraries, including SQL and data frames, the ML Lib for machine learning, GraphX, and Spark streaming. And then you can combine these libraries in any way you want in the same application. And then you can run Spark on a standalone mode. We'll go over what we're doing when we talk about the demo. You can run it on EC2, Hadoop, Yarn, Mesos, or container technologies, Kubernetes. You can access all kinds of data stores. You could do HDFS, Elixir, Cassandra, which we'll be focusing on, other Apache stores, and then other data sources as well. So a few use cases about using Spark. For us, we'll just be covering using SQL and using SQL on a NoSQL database like Cassandra. And I have a couple links here where you can go within yourself or by yourself, and you can click on them, a little more information. A use case for using the SQL drivers, etc. You can use BI tools to essentially visualize your data and make data-driven decisions using tools like Tableau, I believe Redash, I believe Metabase, but there's a link there if you want to check out some others from Databricks. So Databricks is also founded by the same people who made Spark in the first place. So another, like we mentioned, ML Lib. So machine learning is a big use case of Spark. So there's 2 ways you can do it. You can use Spark's ML Lib, or you can use PySpark. We have a series that one of our team members is doing, Obi, and he's taking Spark and Cassandra and doing machine learning on top of it. So you can click on our YouTube link here and then check out those videos. I think he just wrapped up part 4 yesterday, and I believe there's 2 more parts still to go, but it's a great series if you want to learn how to do machine learning using PySpark specifically in Cassandra. And if you want to read the blogs that go in tandem with them, you can click on the final link in that list. Another big use case for Spark is ETL. So a use case in real life, Databricks, again, people who made Spark, they use ETL pipelines for using genomic data transfers on top of Spark. And there's a video link that you can click there. And then also another big one is streaming. So Netflix uses Spark for real-time processing to provide online recommendations to its customers. So going back to the shells we mentioned, so the main one that we'll be using in this demo is the Spark shell. And you can see here what it looks like. In the main language the Spark shell runs off is Scala. And then there's also the PySpark shell, which you can do Python in. Again, you can build mini apps within the shell itself. You can retain data, you can use your variables, etc. You can print stuff, and we'll play a little with that in the demo. And then there's also the Spark SQL shell. And it looks a little bit different when you return values. Is not in the tabular data frame format. It comes back just as listed data, but it does give you some analytics about the time taken and the rows fetched. So if I move back to PySpark, you can see, actually, we'll visualize that in the demo. And then also accompanying running Spark, you can access their UI. And then you can see your jobs. You can see the stage breakdowns, the DAG visualizations. And you can also see per SQL statement what the details are and the breakdowns. All right, going into the demo, for us, for simplicity's sake, we're going to do everything with DataStax Enterprise, because that in a local development is free when you're doing it for development purposes, and that will account for our Cassandra, Spark UI, and Spark Shell. We can all do that within one DSC installation, and there's some links attached there if you want to take a further look. We'll also be using DataStax Studio for a notebook that I created. So we're going to be seeding and creating tables. We can do that with Spark and SQL, and we'll go over that in a second. But just for simplicity's sake and to make this as streamlined as possible, I did it for you. And then if you prefer it to run DSC from Docker, I give you the links for it, and the same thing with DataStax Studio. And then the notebook's also linked here. And then if you're using standalone Spark, and you're doing bring your own Spark, and if you're using just straight up Apache Cassandra, excuse me, I'll show you the doc on that in a second. But essentially, that gives you, DataStax has given you a 5-minute quick start for how to connect Spark to a local instance of Cassandra. All right, so let's go ahead and get started with the demo. So again, this is the DataStax docs I was talking about, the 5-minute quick start. So we'll be using DSC, and DSC already does all of this for us. If you want to do this with your own instance of Spark and your own instance of Cassandra, you can follow these instructions and do a 5-minute quick start. Within Spark Shell itself, we're going to be using spark.sql, and the Spark comes from the Spark instance, and then the SQL is just a function that will essentially take our SQL statement and transfer it into Cassandra. Here, you can, like I mentioned, you can use Spark's SQL to create a database, create a key space, create a table within there. But we're just going to be focusing on doing simple SQL right here. So selects and joins. And this function here called show, what this does is also this SQL statement returns your query in a data frame, which is essentially a table with named columns. And it'll return up to 20 rows just to visualize from this show function here. If you didn't have this .show, it would just return, I'll show you in a second when we get to actually running the demo, what the differences are when having .show and not having .show. And then you can also, in this quick start, it'll show you how to use their data frame functions to save data to Cassandra. So we'll start with the notebook. We're going to go ahead and download it from here. It's linked into the slides. So we'll go ahead and download this. All right. And so let's go to our terminal. So we're going to go ahead and start our Cassandra instance. And when starting Cassandra on DSC, we'll need to start it in the analytics mode. So when we cd into our DSC installation folder, we're going to run bin DSC Cassandra-K. And when you attach it with -K, it's going to start Cassandra in analytics mode. So we'll just give it a second to run. And while that's happening, we'll go ahead and open DataStax Studio. So we'll cd out of there, and we'll cd into DataStax Studio installation, and then we'll run server.sh, and then that's starting our Studio instance. So our Cassandra is running. So now if we want to start our Spark instance, all we have to do is do bin dsc spark, and that's it. If we want to run PySpark, you just instead do PySpark. If you want to run SQL shell, you just go like that. So in this demo, we'll just be focusing on the Spark Scala shell, and just give that a second to run. All right, it's creating a new Spark session. Our Spark session is available as Spark, and that's what we'll be using with Spark.SQL. You can also use Spark context and access it with SC, and this tells you that your web UI is running at localhost 4040 and other information that you can access when building a mini app within your shell. So now we have our shell. So now let's go to our studio. So we'll go to localhost 9091 and refresh that. And now we have DataStax Studio. So that tar file that we downloaded from Google Drive, our demo notebook, all we need to do is drag and drop, and that's it. Boom. Now we have our demo that we can use. So starting off, actually, let me do this real quick. Let me bring them to the same screen. Okay, so from our terminal, in our Spark shell, we're going to do spark.sql, and you're going to have to encompass your SQL statement in quotation marks, otherwise it's going to throw an error. So we're just going to see what schemas we have in our current database. And we have these that we can use. Right now, we want to create a key space called demo. And all we need to do here is click run local quorum and hit OK. And that's going to create our key space, our demo key space that we'll be using. So if we go back to our terminal and rerun this, we should now see demo. Great. So now if we want to use demo, like how we do in SQL, we're just going to change our statement to do spark.sql use demo. And you can have the show there or not, but we're not returning any data, so it doesn't really matter. So now if we do spark.sql use or show tables, don't forget your question or quotation marks. Our key space is empty, which makes sense, right? Because we haven't created any tables. So if we move to the second cell in this DataStax Studio notebook, we'll need to select our key space, the one we just created, demo, and then we'll just run the second cell, which creates a table using about spacecraft journey catalogs, and it's pretty much it's a way we're just going to connect it. I just took some data. All right, so now a reason also that we're using DataStax Studio, if you didn't attend our last webinar about Presto, where we use the same exact notebook, we're seeding 1,000 records. Seeding 1,000 records in CQLSH, it's chunky, doesn't look good, and who knows if you run into an error, that's 1,000 records you got to look through if it doesn't point it out. So we're just going to seed it through this. We're going to select our key space demo, and we're going to run it. I'll show you. So if you're using a local instance of Cassandra, and you're using a local instance of, or if you're using Apache Cassandra or some kind of other variant or distribution, and you're using a standalone SQL cluster, again, like I mentioned, this quick start will show you how to connect it. So like in this config, you'll have your connection host 127. If you have your Cassandra in the cloud, obviously your host name would change. But moving back here, so actually let me go to our downloads real quick. So if you can still take this tar file, the notebook, and when it's extracted, you can open this code.txt file. So if you want to not use DataStax Studio, you can still take the notebook and take the CQL statements that I've already created for you. So again, like this is 1,000 records, right? Your insert into whatever, and that's just, it's a lot. So if you just want to make this easy on yourself, just use DataStax Studio. But again, if you just want to copy and paste into CQLSH, you can do that as well. All right, so moving back, so we've seeded the first table, and now we're just going to confirm. So in the third cell, we're going to select from the table that we just made and where we have an item with a spacecraft name Vostok1. So if we run that, we get our data back. Great. So now if we take the same exact statement and put it into Spark, can we run it? So if we do spark.sql, don't forget your quotation marks. And also another thing is when you copy and paste like this, you want to delete semicolons because that will throw an error using Spark SQL. And then we're just going to do .show. See, it's indicating stages. And now we got our data back, and it's the same exact thing we did with CQL. And also, like I mentioned, if when we have .show and not .show, we can just run that, and this is what your result would be. And again, like I said, we can persist and kind of build mini apps within our shell itself. So if we just say var results equals spark.sql, so now we have it stored in there. So now if we do in Scala, like a print, and we're just going to print results, we're going to see that it's there. And then if we want to see the exact things, we'll just append a .show. Now we got it. We have a stored variable that has our returned query data. But we'll move on from this. This is just showing you what you can do with that. So now moving on, after we've confirmed that the first table has been seeded, we're going to go ahead and create the second table. So the second table is about spacecraft speed over time. So with the goal of using SQL on Cassandra for this demo is we want to take spacecrafts from the first table and we want to get the speed of those spacecrafts from the second table. We can't natively do that with CQL, but we'll be able to do a join statement with SQL. And again, also one thing to mention, you can also run Spark SQL within the DataStax Studio notebook, which makes it even easier. But you may run into issues with always on SQL and enabling it, and you'll have to mess with some DSE files. But we won't cover that right now. But if you run into those errors, you can just Google it. But we'll go ahead and create the second table. And we'll go ahead and do that. And then we'll run a show tables query just to confirm that the second table was created. And it was spacecraft speed and spacecraft journey. So now we'll seed that second table. This seed is a little bit smaller just to make it easier for ourselves. It's about 18 records, but we're just going to seed the second table. And it was confirmed. So now let's copy and paste, or let's run this next cell, which is going to confirm that the second table was seeded. So we're just doing a select all from that table. Like I mentioned, it's only 18 records, so it's not huge. So if we copy and paste this into our Scala shell, so spark.sql, get rid of any semicolons, .show, boom. And also, like I mentioned, that .show has a limiter of 20 records it can show. So if I change this from select all from spacecraft speed over time, we'll do spacecraft journey catalog, which has 1,000 records, but it's only going to return the first 20. So you're only showing top 20 rows, at least in the visualized row. So now let's go into our main reason for using Spark and Cassandra for this demo is we're running joins. So we're going to try to run a select statement, which will take the spacecraft name from the first table. It'll take the summary of that journey from the first table, and then it'll take the speed of that aircraft from the second table based on the journey ID from both tables. And we're going to run an inner join, so it's going to take matching records. And then if we try running this in SQL, it's going to throw an error, right? Because there's no viable input for inner join. So if I copy and paste this into my Scala shell, so if I do spark.sql, paste, and then just get rid of any extra items, .show, I have a data frame that has returned joined data from two NoSQL tables that we didn't have to programmatically do. We were able to run SQL joins using Spark. And so here, like I mentioned, we have the spacecraft name from the first table. We have the summary of that spacecraft's journey from the first table. And then we have the speed of that spacecraft based on journey ID from both tables. So that's about it from the main demo part. So now we've demonstrated that we can run SQL and joins on a NoSQL table like Cassandra, or NoSQL database like Cassandra. So another part of the Spark is the UI. So the Spark UI is at localhost 4040. And so here we can see all the jobs we ran. So we can see all the statements, and we can see where it's coming from. So it's running from the console. We can see the stages, durations, tasks. So if we look at the event timeline, we can see further data breakdown. If we look into our stages, if we click on a random one, so I guess those are completed stages, what we want to click on. So let's see, this one's 100. So let's see, we can see the tasks. We can see further information about that. We can see the host, so we can see where those tasks are happening on. We can see the launch time. Let's see what else we want to see. Yeah, and then if we go into the DAG visualization, we can see how the task breakdown happens and how the RDDs and partition searching and how the stages are working. And then if we go into our SQL tab, again, like I mentioned, you can just see all the number of queries that we've run so far, and you can see further breakdowns of the DAG visualization as well. All right, that wraps it up about it from the demo. We will move into the questions here if there are any. Shared links. Richard, like I mentioned, when this video goes up on YouTube, the slide deck will be attached, and you can click on all the links that you need. And that's why I provided it like that. If you want specific ones, you can reach out to us on Anant, and we can send you the slide deck ahead of time. But it should be up tomorrow if you want to check on our YouTube page. And that wraps it about up. Thank you for joining us here at Anant and the Spark and Cassandra webinar. Again, this was part 2 of our doing SQL and reporting on Apache Cassandra using open source tools. The next webinar in this series is going to be on notebooks that you can use SQL on and reporting on Cassandra. And if you want to reach us at Anant, you can reach us on our website. You can email us at solutions, or you can call us at the number listed. And that's about it. Thank you for joining us.